Okay, perfect. So thank you for inviting me to present part of my work. My name is Marta Sapena. I work for the German Aerospace Center, and I also work on an FPCAP action in a different topic. So we prepare some tool to map urban growth in African cities. We had a few workshops with users, and we came to the conclusion that a tool like this to map how cities are growing in Africa, it was necessary. So I will show you today the result of our project. And as a bit of background to know why studying urban growth is important, is that already since the beginning of the 21st century, urban areas are home to the majority of the population, and climate change or upgrading living conditions are two well-known factors of this urbanization process. The United Nations predicted that this imbalance between people living in urban rural areas is going to increase in the coming years. However, this growth in urban population will grow much faster in Africa or in Asia, for example, which will put extra pressure and will bring new challenges in these regions. And that is highly relevant since more than half of the population living in sub-Saharan Africa live in deprived conditions. So the challenges related to this process of urbanizations are reflected in the intergovernmental agreements of the Sustainable Development Goals. For example, to end poverty and to build sustainable cities are two goals that are related to urban areas and poverty. Monitoring how urban areas grow provides information that can support decision making. And by studying how urban areas grow and the impact that this has in climate and pollution, researchers and planners can develop effective strategies to mitigate these negative environmental impacts or enhance urban resilience, ensure a sustainable development, and so on. Since urban areas are emitting more greenhouse gases, they have created the heat island effect, they have poor air quality, and so on. But for that, we need update and accurate data and information, which is crucial. However, most of the countries in Africa lack this kind of data. So that's why we created this tool that uses Copernicus Sentinel data, because it brings the opportunity to work on a large scale, is free of cost, it has a consistent coverage and a high resolution, and we use this to define indicators to characterize human settlements. So now I will show you how this tool that we develop works. We use Sentinel data to map urban growth over time in Africa. The current status of this is we prepare, the tool is already finished and is already working, but it's not yet publicly available right now, but it will be in the following weeks, because we prepare a research paper where we explain all the methods that is behind this tool. We tested in several sites in Africa, and right now the paper is public as a preprint, but it's currently under review, and we are now working on the corrections. So it will be, as soon as the paper is out, we will release the tool, and I will tell you later how you contact me. You can contact me to get the tool or access to the tool. So the objective of this tool is to produce a 10-meter annual 10-meter resolution annual map of built-up areas in Africa using both Sentinel-1, which is the radar mission, and Sentinel-2, which has the multispectral data. And some characteristics of this tool is that it's computed in the cloud, so it doesn't need resources from the user. It can be applied to any area of interest in Africa. It's automatic, you will see later. It's not visually very appealing maybe, but it's very easy to use. We also prepare a tutorial, a step-by-step tutorial that we will share with the users, and there are only 2 steps to follow. As a difference with other products, in this case, we train local models. So it's not a global model that creates a map. It's really site-specific and created for every specific city or site that we want to map. As a result, the user gets a map and an accuracy assessment that tells you the accuracy of the map that is produced. And if the result is not satisfying, or the user finds some errors, the tool allows to fine-tune the map to improve it by including additional training data. I will show you briefly an example. So I said that is it a cloud computing platform, and for that we use Google Earth Engine. which is a tool that allows you to use an archive of satellite data. In this case, they have the Sentinel data there available. And then you can develop your own algorithms. That is what we did to create this tool, to just apply it to several cases. So the only requirement for users to run the tool is to have a Gmail account that you will need to use to apply for access to Google Earth Engine, which is free for academic and research use. So you just need to have an email account, register, and then you automatically get an account. And by opening the tool, then automatically you will have access to what I will show later. And how does it work? What we do is we use as reference data to learn in our model built up areas by using the new data from Google buildings. And this data is produced for 2021. So what we do is to collect all the Sentinel data for this time. We also use additional data from slope of the terrain. We create statistics from the different bats of Sentinel, and we create a lot of parameters. And at the end, we train a classifier, which we apply to map built-up areas in 2021, but we also transfer this model to previous and following years. And at the end, what we create is a map that has for every pixel the year that was detected for the first time as built up. In this case, just to mention that since we are using Sentinel data, we are restricted to 2016. So this is the earliest year that we can map. And right now we are using it until 2023. But as soon as the Sentinel data is fully available for this year or for the following years, this will be also updated. So this is how the tool looks. If any one of you already use Google Earth Engine, it's just a browser, so a website in a browser that you open, and you will see some code, which is what is behind the tool. So this is useful for those users that have a little bit of experience programming, because then you can understand the code, you can adapt it, you can modify it. But if you don't have experience, I will show you, you don't have to do anything. It's just to change one line, and I will tell you how, but it's also visible in the tutorial that we prepared. So the tool is consists of 3 different files. We have 2 steps, which is the sampling data and the mapping. And we created also a third one recently, which is just to view the map. So once you have the map, if you want to visualize it, but you don't have any software to do it, you can also do it through the tool. Then we have, once we open one of these files, we have the tool, then we will see our results on a menu on the right, and then we have a map. So the first thing that we have to do is to go to the first step. In this case, in this step, we will create training data. And here I show you an example. The first thing that we have to do is, okay, I want to map how Cape Town growth in the last 5 years. So I go to the area and I draw an area of interest, which is a polygon that I will assign some name. So the only thing that we have to do is in the code modify the area of interest name. So we will assign the name of our polygon and a name that we want to assign for the output map. Then optionally, we can set the country. If is left by default, it will work, but Google Earth, the building dataset from Google doesn't have buildings in Morocco, Mali, Libya, or Chad. So in those cases, we use Microsoft buildings. So if the user sets here that his area or her area of interest is in these countries, then it will be able to retrieve data from those. And optionally, you can set a specific coordinate reference system, otherwise it's using one by default. So then the user will only have to run the code, wait a little bit, and in 10 minutes, your reference data is created and is stored in your account. So no one else will see this data, but in your account, you will have this sampling data. The next step goes to the second script. Here it's called second step. Then you will open. And the only thing you have to do is to make sure that you assign the same name as before. So before I name my area of interest Cape Town. So I also set it here. And then I just run. As you see, you don't have to modify anything. If you want to dig deeper into the code, that's possible. It's a very long script. And then you will learn how to filter the pixels by the cloud coverage, how all the training process works, how we are fitting the model, and so on. But if you are just interested to create a map, you don't have to do anything else. And in this case, since the area was a little bit big, it took 20 minutes to create the validation report, because we only create this for the year 2021, and 2 hours to create the map for 6 years or 7 years. It will always depend, the time will always depend on the size of the area of interest. But something to mention is, since it's computed on the cloud, you can just run the code, close close the window, turn off the computer, and then in 2 hours you just log in again, and then you will see your result. The tool is working in the background, so you don't need to be even within the internet network to run this. So then once the result it's computed, it's stored in our Google Drive, and you can just directly from the tool click, and then you will see that you have your map and your accuracy assessment. So you can just download it. And as I said, if you have any software like QGIS and free software for this mapping, you can use it, or you can use our viewer that we created. And for that, once you downloaded the map, you can import it easily into the assets of Google Earth Engine. This is also part of the tutorial. I just wanted to show you that it's quite easy. So you download the file, and then you upload it again into Google Earth Engine, and you open the script, and then you just set the name of your map. And automatically you will see this is just a zoom area of Cape Town, where we can see in the light orange and yellow colors the new development, like the year of the construction. But now I want to show you a few examples. So here it's with a different scale color. With the is the same. So this is Cape Town, the product that we just ran, and you can see in dark blue the oldest built up areas, and in red and orange the new developments. So if we zoom in some of the areas, for example, here you can see that it detected that this area here in the city grew between 2018 2019, and we also have those orange areas here that were developed mainly in 2021. So it's very detailed, and we can really see the different time frames where the city is growing. And so here you can see, because maybe in this image it's not very visible, but this is very dense urban development, probably in the shape of slums or some informal development, but it's still able to detect it. Then we have other areas in the city, in the north of the city, that develop quite fast. And here you have an example. On the left, we have an area that developed quite formally with very structured morphologies, and we can even see different years of period where this development took place, but also in this area on the right, on the south, where it's more again like this kind of dense development, and we can also see that it took mainly place in 2020 or 2021. There is also another example in the north, where we also saw very organized development, and it can also be detected by the tool. So
Two
as
minutes,
I'm
Marta.
Okay, then I have to speed up. So then, as I said, if the user finds, because it knows the area of interest, some errors, there is the possibility to fine tune. And for that, we will have to run the tool again by pointing to some polygons where we found some mistakes. So the tool creates additional training data in these areas, and you can produce a new map. And I just wanted to show a few more examples. For example, here, this is another product in the Democratic Republic of Congo. I want to highlight these areas that we have some gaps here in the data, and this is because of clouds. So it means that in the since 2016 to 2018, we didn't have a pixel without clouds, and this can be somehow being confused with urban development, but it's also useful to see that we identify some growth in the outskirts of the city. And we also did it for several cities in Africa, like we have Morocco. Okay, we have in Botswana, also in Libya. So we tested in very different environments and agroecological zones to see that our algorithm was working for different sites. And maybe very briefly, I will go through some applications or how are we using this tool or the products created with these tools. And something that I mentioned is that since we are using Sentinel, we are only able to map since 2016, but the DLR, also German Aerospace Center, also developed a product that is called the World's Element Footprint Evolution, which uses Landsat data and it's mapping built-up areas since 1985 to 2015. So what we did is it's a data fusion of these two data sets. So what we do is to have a very long-term urban growth of African cities. So I want to show you just a few examples. For example, in Lagos in Nigeria, in yellowish color, we have the recent development. We also did it for Ouagadougou in Burkina Faso or for Accra in Ghana. So we have a very long-term evolution of these cities. And okay, also very quickly, we applied this to 300 cities in Western Africa because we also had another research project going on in Nigeria, Ghana, and Burkina Faso. And we wanted to compare the urban growth in cities with more than 50,000 inhabitants. So what we did was to produce this map for several areas so we can compare how fast they were growing. And we can see here in this plot, for example, that Kumasi is a middle growth report. The previous one, Pakuro, is one of the most growing ones, and the same for Gyosa, which is the one that it grew the least. So with this, we can make some comparative analysis, and we can see how different cities across countries in Africa are growing and what implications this has. So just to conclude, to mention that we hope with this tool, we can decision makers can use it to monitor fast urbanization processes in Africa. Also, the tool is transferable. Right now, it's only developed for Africa, but it can be also applied to other continents or countries. It's scalable in time, so we did it in a way that as soon as new Sentinel data is available, it will also map new development and new so for every year. It's multifunctional. So as I said, the script and the code will be available, and users that are interested in how to produce cloud-free mosaics of Sentinel data, but maybe interested into green spaces, mapping urban green spaces, they will be able to use most part of our tool to adapt it to their own problem or their own application. It's open source, so we will publish the code, as I mentioned, and it's also heterogeneous. It means that we really tested in arid landscapes, humid landscapes, and different agroecological zones in Africa to really make sure that the accuracy was not very dependent on the landscape. So here you have my email address. So if you are interested into the tool, since right now I cannot share the link because it's not public, but I hope it will be in the following weeks. So you can just write me an email, and as soon as we have it, I will send the tool and I will send the tutorial and all the information. Or if we are going to do some training or something and you are interested, we will also share this information. Thank you very much.
Okay, thank you very much, Marta. You have 1 minute for QA session, but I think you just please note that Marta's email address here, and the slides will be available. But I still would like to have one or two more questions to be at or pick up from the chat, if there is any chat. Let's see, or just somebody speaks quickly that we can ask Marta before we close.
Can I do a question?
Yes.
Yes. Hi, Marta. So just a quick idea how you do the validation of this tool, and if there are any plans of, or if it will be easy to transfer it to the Copernicus data space ecosystem instead of using the Google Earth engine, if you...
So for the validation, as I said, as training data or reference data, we use the Google footprints, building footprints. And what we do is a random selection of buildings. And we also use land cover maps to have a stratified sample of different land covers. So we just train a model with 70% of our sample, and then we leave a percentage of the sample that did not participate into the training, and we make the validation with this. In the paper, we are also conducting an evaluation with an overlap. So we are testing our maps with global products that exist nowadays. So we are also making this validation for at least 100 different sites in Africa. So we provide some indicators on the accuracy and regarding if it's possible to implement it in, yeah. So I think so. I think it will be possible because, of course, we use the Sentinel archive, and what we are just using is the API from Google, and right now it could have to be adapted, but I don't think that would be a problem. It's just possible to extend. We also want to use this for other continents or for Latin America and so on. So we are also trying to think how we can adapt this to other environments. So yeah. The code, there is also one question. The code is not available right now, but it will be in the coming weeks. So users will be really able to even copy or modify the code to improve or to adapt it to other solutions. So yeah, it will be very soon.
Okay,
So,
thank you very
maybe
much.
maybe we can suggest that when it's released, if you allow us, we could share with all the participants of the work of this webinar so that they are
Yes.
aware that it's
Yeah,
released.
of course.
Thank
Yeah,
you.
yeah. That's perfect.
Yeah, we
Yes.
will have an email list that we can have basically share this all these developments. Actually, also for Walid for other speakers. Yeah, there was a okay, but there was in chat something that you can maybe write when I was finishing this. Marta, maybe you answered that. So I would like to close this webinar, but before closing, I would like to thank very much our speakers for their time and for their very interesting presentations. And I would like to also thank you for our this the work package leader, Carolina, which is the in charge of webinar organizing webinars for this. It has been big work on behind, and also actually Marietta and Dimitra for our all this everything works smoothly. I would like to thank, and I would like to close here webinar 2, and there will be repeating webinars in French and Portuguese. So if you are capable of those languages, welcome to participate. But please don't hesitate to contact us. Further collaboration, further ideas. We will be continue of organizing this webinar series, and our activities will continue at least this one next year, September 2025. So yeah, thank you very much. I don't know if Carolina, you would like to have something to add, final words.
No, just saying if you are interested in the French and Portuguese webinars, the Copernicus presentation will be the same in different language, but there will be different use cases presented by different institutions. So feel free to register and participate also. Thank you.
And thank you very much, all our participants, so your interest. And yeah, I'm closing the session now. Bye bye. Have a
Thank you.
great
Bye.
day, all.